Hello everyone, welcome to Gyan, a channel where we get to learn everything about data science. Well, in the previous videos, we started talking about named entity recognition and relation extraction. We started by understanding the NER and relations extraction, the very basic essence of these two. Then we went about doing the data labeling on a Label Studio. And then in the previous video, we talked about the custom NER done on spacy. We created a blank model and then eventually we trained it to perform some specific task. In this particular video, we are going to now talk about the transformers pipeline into a spacy 3.0 version. Okay, this is an important enhancement to or addition to spacy wherein we can add any of the transformers pipeline and further train the spacy to build a custom NER model. Okay, so let's get started with the coding. So we first start with importing the libraries. So we have imported numpy as np, pandas as pd, os, json, glob, and RE, TQDM, and so on. And then we install the spacy-transformers. So we just need to do pip install -u spacy-transformers. It will add all the dependencies as well, like the PyTorch and so on. Okay, so it will take some time essentially to install this, and it will also add the transformers into the spacy pipeline. Now, if we remember from the previous video, we essentially have the data with four classes. Per is for the person, time for date and time, org entities for organization, and LOC for the location. And if we look at the raw data looked like this, where we had essentially the sentence and the text stated like thousands of demonstrators have marched through London to protest the war, etc., etc. And then once it was annotated, then it looked like this. So we had the sentence number, we had the text, and then we have the label. Now the labels could be multiple here for a particular sentence. So we have start, end, and the label related text and the label related category here. Okay, so this was the data. So we'll read the file name. So the file name is essentially label underscore studio annotated underscore json.json. Now, like we did in the previous video, we'll create the train data, and this will just need to contain the start and the labels along with the text, right? So these are the four things that we need, and rest of the stuff from Label Studio will essentially discard. So my data would look like this. So we have the text and we have the list of the entities here. So 48, 55, LOC, and so on and so forth, right? And in the previous video, we also briefly touched upon the overlap of the entities or overlapping entities. Okay, next we'll do a train test split. So we covered this in the previous video. And once this is done, now we'll move on to some of the specific steps for training the model. So we will be importing the spacy here, and from the spacy.tokens, we'll import docben. Now, docben is very important to understand this. This is more like a serialization right tool, and very much similar to what Pickle does, but then the document says that it's in fact faster and creates the data which is much smaller in size. Okay, then we will load the new spacy model, a blank model, spacy.blank en, and we'll create a docben object here in db. So db is equal to docben and parenthesis. Now we'll measure the progress across all the row items of train data. For that, we'll do the TQDM, and this will show me the progress bar, right? And essentially, the train data has two parts here: on the text and the anode. So for each text and anode in the TQDM train data, we'll create the doc object for the text. So we'll pass it through nlp.make underscore doc, and this will create a doc object for me. We will have an empty list of the ENTS or ends, and in this we will store the start and the level values and that are present in anode entities. Okay, like what we saw here. So we'll go to anode entities and we'll capture start and level. Okay, so then from this, we will create the span object here. So doc.char underscore span. This will give me a span. And this needs the arguments like start, end, and level, right? And the alignment mode is set to be contract, which says that all the tokens are within the span itself, right? So there is no partial containing containment of the token within the span, the character span or the text span here. So then if the span is none, then we pass this, or else we append it to our list here, the empty list, and this will keep getting filled for all the possible combinations here. So we have the doc.ents then, which is then given the value of ents ends. So now we'll add the db dot to the db, the doctrine object that we created with this doc, right? This doc, as you could see it earlier, first it contains the text, which is nlp dot, which was done through nlp dot make underscore doc text, and then it also contains all ents, right? All the entity related or all the labels we'll be doing, and then we essentially send the db to disk. So when I do this for the train part of the data, that the train underscore data, in fact, we'll be getting train dot spacey. So in my output directory, we can see that we have the train dot spacey. Okay, so this spacey object is what we have got. Next, we'll do the similar work for the test underscore data as well. So we run it through the same set of the code and we get test dot spacey as well. So since I have already run it once, so that's why you you find it readily here. So you have the test dot spacey here. Okay, so now my data is ready, and the next step for us is essentially to get the config file, right? So we will get the base config file from https spacy.io usage training quick start. So when you go to quick start, then we essentially get this file. So the way to do it is we come here and we'll go to NER, we'll set it at GPU transformer, and then we need to define whether we want to train it for efficiency or accuracy, right? And post that, either we can copy paste this config file or download it here. Okay, so I've already downloaded it, so I will just make use of whatever is made available to me. Okay, so then we get the file here. So we copy the spacey base con from the spacey base config cfg. So from this folder, we essentially get the base underscore config.cfg. So I've kept the file in this folder itself. So base underscore config.cfg, and and then this has to be copied to my folder where the model will reside. So this is my working folder where, so my model will be here in this toggle underscore working. So we essentially need to have this config file copy pasted there. So that's what is happening in this step. Okay, so we run this and we also see that my base config is copied here. Let's quickly see as to how it looks like. So we'll download it, we'll keep it uh, and we'll see. So these are the few things that you'll see in the base config.cfg. Like it has got the paths for train, dev. In this case, the GPU allocator is PyTorch. The pipeline contains two pipes, transformer and the NER. Batch size is 128, etc., etc. You can also define your custom config, so we can change these default values and we can come up with the settings which are much more closer to our requirement. After we have converted this base config to the config.cfg. Now, what is that step essentially? And this step, the step number 2, will be initializing the base config file and then we will init with the spacy init, which will initialize it and will add the most common settings. So the in the base config.cfg, you'll find that some additional settings will be copied. Let's see what are those settings, right? So essentially the learning rate and the dropout rates, etc. The common settings will be actually provided and copied in the config.cfg. So it will be a much more elaborate version of what we saw under base underscore config.cfg. Okay, so we have config.cfg again here in my output. We'll see how it looks like. So we'll keep this file, we'll open it and let's see this. So we have config, in this case train, def, vectors is null, init, talk to vec. These are some additional values or fields that we are seeing, right? And then the seed is now set to be 0. The length is same, pipeline is same, batch size is same, and so on. So, and then if we go further down, then we see that uh, we have essentially added some of these components like accumulate underscore gradient. I think this is already there with the base config, but then some of the other components like dropout, patience, max epochs, max steps, evaluation frequency, I think these are some of the additional settings which have been added here. Okay, so now it's entirely on to us now to change these settings, upload the new config file and train the spaCy model as per the new config. Okay, so that's about config.cfg. Now that my configurations are set, right? So then we need to train the model in this way, where we say spacy train Python minus m spacy train and train it using config.cfg. That's what we are saying it here, and deposit, and my output is essentially into slash output, right? So in this particular folder, and then path.train. So the path for the train data is essentially train.spacy. So this one, train.spacy. And paths for dev is the test.spacy. And in this case, I'm using GPU and GPU P100, and that's why we have GPU ID 0. In case we want to train it on CPU alone, then we'll put it as we'll sort of remove this part or hash it. Okay, so that's the command for training this PC model here. One more time, we essentially started training with the config.concfg. It is residing in the same directory where we have the model supposed to be residing. My outputs, I have provided the path to the output. We have provided the path to train and test or the dev related data. In case you do not have the dev related data, then you can just put it here, train.spacy, right? Both the paths are provided, and then we have also provided the infra here, which in this case happens to be the GPU. Okay, okay. So here we have already started doing the train, right? So we have the loss being reported, and for the NER, and we also have the scores being generated, right? So this will run for the several different iterations, and I think the checks like we had defined in the config.cfg, it will happen for every 200 iterations, right? So we'll just wait for one iteration to complete, and then probably we can check as to how the score looks like. Okay, so we are now done with, in fact, 200 iterations, and we see that a score of zero point 0.6 is what it has given, right? We'll stop the run here, right? Because it might take more time to run it. I think a score of zero point 0.6 can definitely be improved, and when it comes to named entity recognition and so. Okay, now let's see how the output essentially looks like. So we will refresh it, and so we see that there are two different subdirectories created under the output. The first one being model hyphen best, and the second one is your model hyphen last, right? So either you can use the best model amongst all. We just had 200 iterations here, so from there whichever is the best, or the one where we just stop the training process, we can pick that particular model. Okay, so let's take the best model from here. So to do that, it's a simple command which says spacy.load kaggle, and we give the path. So in this case, model hyphen best. Okay, so this will now load the custom model that we just trained, right? So my best NLP is the spacey model we just trained on, and we have loaded it now. Now let's try to see how it performs on a sample text. Okay, so we take a doc, and we create a doc using best underscore NLP or best model. And my text is Bill Gates and Paul Allen founded Microsoft in Seattle in 1980. Pardon me for the exact year. I do not know whether it was 1980, but somewhere around that time, I believe it was founded. Okay, so let's leave that aside, right? So we have this particular model, do its work, create a doc, and then for a better visualization, we'll color code the document for the entities that have been identified. So say for example, in for per related entity, we'll use this hexadecimal value, LOC will use this, or will use this, and time, I think this is the green color, which has got the hexadecimal value of this one. Okay, and then we have the options is equal to colors. Colors will use spacy dot displacy. Okay, this displacy essentially will render it in it very nicely, right? And these are the arguments where you provide the doc, the spacey format of the text, and then we, in this case, the style is ENT, where the ENT has to be identified, and we provide the colors as the options, and this is the Jupiter. Okay, so here we get the output or the result. So this essentially color codes the person related entities. So we get in the pink color. So we have Bill Gates and Paul Allen in the pink color. They have been both identified to be PER or person related entity. Microsoft is LOC, which is wrong, right? So in this case, there is one entity, and that's why we had got a result of or a score of zero point 0.6. This model definitely needs to train a lot more, or should be trained on more data. We'll have to experiment. And in Seattle, Seattle comes out to be correct. So in Seattle, LOC in 1980. Again, this entity is missed. This should have been the time related entity as we got earlier, right? We defined four of the. Okay, so that was it, folks. And I hope that you liked this video. In the coming video, we'll be talking about the transformer models and how do we train the transformers essentially for the NER task. And then we will delve into the relation extraction models. Thanks once again.